So we can define one-sided continuity as well. So depending on which direction your x approaches, you can define one-sided continuity. Suppose your x approaches x from the right. We put plus sign on the shoulder. So when we are interested in the behavior of function f when your x approaches from the right, then we use this symbol, a plus. And we say the function is continuous from the right when this limit is exactly the function value. Similarly, when your function has the property that the limit of f as x approaches from the left, so when your x approaches a from the left, you take this one-sided limit and you check whether this limit agrees with function value. If two values agree, we say the function is continuous from the left. For example, well, this is the graph from the previous slide, the third type of discontinuity or jump discontinuity. So let me recycle this graph. So for example, this function is continuous from the left because when your x approaches this way, the limit is exactly the function value. However, when your x approaches from the right, this limit does exist, but the limit doesn't agree with the function value. So this graph is continuous from the left, but not from the right. In other words, limit of the function, say that this is a graph of h. In a limit of h as x approaches value a from the right, then this limit doesn't agree with f of h of a. That's why this function is not continuous from the right, but this function is continuous from the left because this limit is exactly function value. So let us look at two piecewise functions to discuss discontinuities and one-sided continuity and discontinuities. So first example is a piecewise function with the 2x plus 1 when your x is negative or 0, and then quadratic function when your x is strictly positive. So you can draw the graph of f using this straight line and then parabola like this. Well, the expression gives you the vertex 1, negative 1. So our function is not continuous when x equals 0, and we want to tell what type of discontinuity. Well, it looks like the function jumps when your x equals 0. So this function has a jump discontinuity at x equals 0. What about one-sided continuity? So when your x equals 0, you can talk about one-sided continuity. Well, look at this. The function value is 1, and the limit is exactly 1. So f is continuous from the left. Okay. For the second function, we need to look at this expression carefully. Well, we can simplify this expression. Well, x minus 1 and the denominator, x squared minus x, have the same common factor. Well, when you factor denominator, we have x minus 1. So you can cancel. Actually, after canceling, we have just 1 over x. So the function is basically 1 over x whenever your x is not equal to 1. And then when your x equals 1, we have value 0. So this function g is almost y equals 1 over x. But when your x equals 1, we have different value, which is 0. That's it. So this is the graph of g. And then our function has two types of discontinuities, one at 0, one at 1. So g has the infinite g has the infinite discontinuity at x equals 0, because we have plus infinity and minus infinity limits. And look at this x equals 1. We have discontinuity, but you can redefine this g to have continuous function. In that sense, g has removable discontinuity at x equals 1. When you redefine this, you will get copy of 1 over x. All right, let us try some advanced problem. So function g is piecewise function with quadratic function when your x is less than 2, and then straight or linear function when your x greater than 2 or equal to 2. You want to control c so that the function is continuous. Let me fix this typo. Instead of this 7, let us use 1. So we have 6 plus 1. So let me redefine this. G is the function x squared minus c squared, and then cx plus 1. Okay, so instead of this number 7, let us use 1. Okay, so we want g to be continuous. If g is continuous at x equals 2, two one-side limits must agree. From the left, and then from the right. When your x is less than 2, we use quadratic function. So limit of x squared minus c squared. And then when your x is greater than 2, we use this linear function. So limit of this quadratic function is simply 2 squared minus c squared. And when you plug in 2, we have 2c plus 1. So if you rewrite, we have c squared plus 2c minus 3 equals 0. So we have somehow nice quadratic equation. You can use factoring or quadratic formula. So to have negative 3, we can take plus 3 minus 1. And then the sum of those two is exactly 2. So c equals -3 or 1. So we have two values so that the function g is continuous.